Welcome back to Just Academy Mathematics, where we make you a mathematics genius. Today, we are going to be learning multiplication of matrices. There are two types of multiplication of matrices. The first is what we call the scalar multiplication and the matrix multiplication. But we are going to be concentrating on the scalar multiplication, as you can see in my write-up here. What is a scalar multiplication? A scalar, that is number. Multiplication of matrix is multiplying every entry or element in a given matrix with a regular number called a scalar. So a scalar multiplication is where you use one single number to multiply a matrix. It's called scalar multiplication. But matrix multiplication, which we'll be doing in the next class, is when you are using one matrix to multiply another matrix. It is called matrix multiplication. So for instance, this is a matrix. Matrix A is given as 3 minus 2, 5, 6. This is a matrix. Now they want us to find 2 times matrix A. So this type of multiplication is called scalar multiplication. It's different from when you use a matrix, another matrix to multiply matrix A. That one is called matrix multiplication. So scalar multiplication is very simple and straightforward. So for instance, let's take on this example here. Now we want to find A, 2A, that is 2 times matrix A. 2 times, what is matrix A? 3 minus 2, 5, 6. So what is the answer? 2 times matrix A. Just use 2 to times all the numbers here, all the entries here. 2 times 3 is what? 6. And 2 times 5 is what? 10. 2 times minus 2 is what? Minus 4. And 2 times 6 is what? 12. This is the answer of 2A. Can you see it's very simple? Now let's see what 3A will look like. B. So we should find 3A. So 3A means minus 3 times in A. 3 minus 2, 5, 6. So what would that be? Minus 3 times 3 is what? Of course, minus 9. Minus 3 times 5. Minus 15. Minus 3 times minus 2 will give us positive 6. And minus 3 times 6, minus 18. This is the answer for 3A. Now for this batch, let's go for the C part, which says we have to find minus 3A transpose plus 2A. If you look at these two we've solved before, you notice that we've already solved for 3A. Then we have already solved for 2A. So to get 3A transpose minus 3A transpose, you just transpose this. If you transpose this, you will get what? The row will become the first row will become the first column. That is minus 9 and 15. Then the second row will become the second column. That is 6 and minus 18. So this is minus 3A transpose now. Then you add what to it? You add 2A. We know 2A. We've already gotten 2A before, which is what? 6, 10, negative 4, and what? 12. So if you add these two, you will get this answer. So what would that be? Let's add. Minus 9 plus 6 will give me what? Minus 3, of course. 6 plus 10 will give me what? 16. Minus 15 plus minus 4. Minus plus times minus is minus. So minus 15 minus 4 is what? Negative 19. And minus 18 plus 12 is what? Minus 6. So this is the answer for minus 3A transpose plus 2A. So can you see? Multiplication of matrix or scalar multiplication precisely is very simple. Let's take another example. Look at this example. We have another good, interesting example now here to tackle. If you look at this example, they say that if f of x is defined by this, is equals to 3s minus 2, and P is equals to this matrix, and I is 2 by 2 identity matrix. Anytime you hear 2 by 2 identity matrix, I will show you what it means. 2 by 2 identity matrix, they want us to evaluate f of x. Now, it's very simple. Look at what we're going to do. Remember that f of x is equals to 3x minus 2. But they want us to find f of p. F of p simply means anywhere you see x, because s is here now, we're replacing it with p. So anywhere we see s, we can put p there. And what is p? Matrix p is what? 2 minus 1, 1, 0. Does that make sense? Now, minus 2. Now, there is something you need to know. You cannot subtract this. After multiplying this, now you cannot subtract it with 2, because you can't subtract a matrix from a single number. I told you in our last class that for you to subtract 2 or more matrices, their dimension must be the same. This one is 2 by 2 matrix. This one is 1 by 1, if there is anything like that, 1 by 1 matrix. So you can't subtract this and this the way it is now. So what do we do to this? We times it by the identity. Identity is like 1. 2 times 1 is what? 1. Anything multiplied by 1 is 1. The identity, or the 1 of 2 by 2 matrix, is this thing they call 2 by 2 identity. That is this I. So you times this one by I. And what is I? 1, 0, 0, 1. That is 2 by 2 identity. 1 from the left to the right at the diagonal. 1, 0, 0, 1. This identity now, 2 by 2 identity, is like 1 in matrix. It's like another way of writing 1 in matrix, in 2 by 2 matrix. So 2 times 1 will still give you 2. So this is 2 by 2 identity. Assuming it's 3 by 3, you say 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. Are you following? The 1 will still align from the left down to the right. So that is identity. So as it is now, we can find f of p to be what? 3 times 2 will give me what? 6. 3 times 1, 3. 3 times minus 1, minus 3. 3 times 0, 0. Then what do we have? Minus 2 times 1, 2. 2 times 0, 0. 2 times 0, 0. 2 times 1, 2. So finally, f of p is now equals to 6 minus 2 is what? 4, of course. 3 minus 0 is what? 3. Minus 3 minus 0 is what? Negative 3. And 0 minus 2 will give us what? Minus 2. So this is the answer for this operation. And that is obviously option D. That is option D. So that is how to solve this. So if you are given a matrix to add, if you are to add a matrix to a scalar number, just a number, a digit, what you are to do is to use that digit to times by the identity of that dimension. If it is 3 by 3, that unit times 3 by 3 identity before you can be able to add. Because imagine if you have this 6, 3 minus 3, 0 here, and you want to minus 2. It's not possible. But we can minus this 2. So this 1, 0, 0, 1 is the 1 of 2 by 2 identity. That is why we call it I is a 2 by 2 identity matrix. Okay, let's solve one more before we close this class. Now, we have another question here involving a 3 by 3 matrix. Of course, this one is still going to be simple. Now, we are given that M and N are 2 matrices defined by, this is M, this is N. Both of them are 3 by 3 matrices. Evaluate 2M minus 3N. Simple. We start, we want to evaluate 2M minus 3N. So simple. We come here, 2 times M. What is M? M is 1, m is 4 minus 3, first column. 3, 5, 2, second column. 2 minus 1, 0, the last column. Minus this minus here. Then 3 times n. What is n? 1, 4, 2, first column. 3, negative 1, negative 3, second column. 2, 5, minus 1, the last column. So this is scalar multiplication, scalar multiplication. Use these 2 to times everything here. Use the 3 to times everything here, then you minus. So let's go. 2 times 1, 2. 2 times 3, 6. And then 4. 2 times 4, 8. 2 times 5, 10. 2 times minus 1, minus 2. 2 times minus 3, minus 6. 2 times 2, 4. 2 times 0, 0. Then minus, let's go. 3 times 1, 3. 3 times 3, 9. 3 times 2, 6. I'm not using this minus. Look at the minus here. I'm just times with only 3. 3 times 4, 12. 3 times minus 1, minus 3. 3 times 5, 15. 3 times 2, 6. 3 times minus 3, minus 9. 3 times 1, minus 1, minus 3. So what do we do now? This minus this to give us the final answer. So let's go there. 2 minus 3 is minus 1. 6 minus 9 is negative 3. 4 minus 6 is minus 2. 8 minus 12 is minus 4. 10 minus 3. Minus times minus is plus. So that is 10 plus 3 now will give us what? 13. Minus 2 minus 15 will give us what? Minus 17. Minus 6 minus 6 will give us what? Negative 12. 4 minus 9. Minus times minus plus. So 4 plus 9, 13. And 0 minus 3. Minus times minus plus. That is 3. So this is the final answer for this operation. And that is option what? Option C. So this is how to operate scalar multiplication. This is scalar multiplication in matrix. In our next class, very important, don't miss that class. I'm going to be teaching matrix multiplication. When you have 2 matrices, you want to multiply them. I'm going to be teaching that in our next class. Remember, we are all available. I am available. All Just Academy tutors who have more than enough tutors available to coach you on one-on-one basis. You want a one-on-one basis. Anything you want to learn in maths at all, matrix, anything in algebra, statistics, calculus, trigonometry, geometry, just call us. We are available to tutor you on one-on-one basis. So see you in our next class. Remember to subscribe to our YouTube channel if you have not subscribed, and follow us on all our social media platforms. Thank you.